Today's session is on migrating storage. Could somebody hit the door closed, please? Get the background noise down.
I'm gonna get it. I'll break it now. Close the door.
We're going to be talking about migrating storage without disruption. I've been managing systems for a very long time. Changing storage environments always was a fight over scheduling. When can the system become unavailable? When do we have enough time to do this? How disruptive is it going to be? And on and on and on. That's the fight. If you can get rid of that fight, you will have a much more sane existence. Now, what we're going to show you is how to do that with a bare minimum downtime. Basically bouncing the systems involved once. And everything else, once that you have to do, and then doing a rolling reboot later to make sure everything can come back if you have to emergency crash and restart. By the way, I'm not kidding. You need that second assurance to make sure you didn't make a change and forget something along the way. Do it on a time and place of your choosing, not when the power glitches and you suddenly have a down machine. You can schedule a system restart on most clusters with ease if it only involves part of the capacity. If I tell you I have to take one of the 2 machines or one of the 5 machines down for 5 minutes at midnight, it's normally a non-issue. What is our utilization at midnight? 2%. So you're going to take one of the machines offline at midnight. Yeah, for 10 minutes, no problem. As long as the other ones are on the firing line, you can take one for 2 minutes on Monday, take another one on Tuesday, and so on and so on and so on. As long as it doesn't disrupt operations, you're golden. The whole issue to higher management is availability and uptime. It's actually not uptime of individual nodes, it's uptime of service. So if the machine bounces and there's still enough capacity to handle full load, nobody gives a darn. There'll be no phone calls, no lights on the panel, no urgent emails or pages. One of the machines rebooted. Big deal. The reality is operations is now 24/7, 365. Having backups is critical. You can't shut production down. Huge fight. I have it regularly with client managements. We need to take the machines down for a full reboot. I can give you next Thursday. Oh, wait a minute. We're having Labor Day weekend in 6 weeks. You can have an hour on Labor Day weekend, Sunday night, between 2 and 3 in the morning. Maybe. There is the clients, our customers who are out in the Far East who don't celebrate Labor Day on that day, and that's the middle of their day, and you get the idea. So windows throughout the world are getting smaller and smaller. Availability needs to be measured in years, not days. While you're doing all of this, things change. CPUs have to be repaired, upgrades have to be done, EFI has to be upgraded, storage controllers have to be upgraded, whole storage controllers have to be removed and replaced, drives fail, it goes on and on and on. The name of the game is never dropping the ball. It's like a volleyball game. The ball never touches the ground, or you lose. VMS has had host-based volume shadowing for a very long time. It's normally seen as a way to have redundancy should a disk fail. But in there is a capability that is much more broadly enabling. Obviously, when disk fails, I'm going back to the days of the HSC 50 and going back to physical plain directly connected disks. If a disk fails and you have host-based volume shadowing, the IOs get redirected to its partner. You call field service, you get the bad disk replaced, or you yank it. Back in those days, you needed a forklift. Those damn things weighed 600 pounds. Believe me, I saw one topple once. I saw one topple. The field engineers were in the process of taking it off the skid when we tested. We're testing it on the skid, and they forgot to put the feet down. And the recoil from that motor going back and forth walked the drive over the edge, and it toppled. Ouch. It also needed a head replacement after that.
Too bad.
That was literally downtime. The name of the game with host-based shadowing is you have zero downtime cutover. You plug a new disk in.
Same size though?
Defer. By the way, questions en route, I reserve the right to defer.
Don't spoil the evening.
No, I just say defer. Cutovers do not require restart. System, our application. No notice to user. If the user doesn't see it happen, it didn't happen. The solution with host-based volume shadowing is all your device references reference shadow set devices. You never, unless you do a show dev, you never see what's behind the shadow set number. Ever.
Unless you know how to read.
You can't direct anything directly to the physical memory. It's monopolized by the shadow driver. You can only go through DS, whatever the N number is. Now, if you follow good practice, all references to mass storage is through logical names. A logical name points to a DS number, which is a shadow set. The shadow driver points to some set of physical devices. And as we'll get into later, physical device is now a bit of a misnomer. It's now a logical volume, which is mapped on a storage controller to some kind of backing store. Yes, 4 levels at least. But whatever you do, as long as you're opaque, as long as you're unchanged to the DS device, it doesn't matter. This works on Alpha, it works on IA64, and it works on x86. It even works across them, because shadowing is shadowing is shadowing. So you have a 3 architecture cluster. Guess what? You can move your data volumes, and we do. You move your data volumes across the spectrum while everybody is happily running. Yes, this is like changing treads on a tank. You pull the pin, you connect the new tread to the old tread, and then you drive the tank onto the tread. And along the way, the wheels pick up the new tread. At the end, you lift up the tail, put the pin where it belongs, and you didn't have to jack up a 100-ton object. You just lay the new treads out in front, connect them, and drive over it. Same concept. You're managing storage and redundancy. Louder, please. Synchronizing. Enterprise arrays take this to a whole new level. We'll get into that. That's part of, I think, what was your question. Also, we have logical disks. Now remember, a logical disk points to, a logical disk is pointed to by a logical name, which points to a file name, which points maybe to a logical name, which points to a DS number, which points to a bunch of physical devices, which are logical devices, which are enabled, realized on some storage medium. Count the levels, you run out of fingers on one hand. Yes, it can get a little bit confusing. People get really confused by this. And you start working the layers as, oh, that we moved this, but doesn't that affect this? No, that points here and that. transparent. Look, ma, no hands. Disks are real. By the way, interesting in reality. I had somebody very senior tell me that it doesn't matter. All these access time questions don't matter. Everything is solid state. Okay. Observation. Engineers don't build things that they don't need. Every single solid state storage device of any capacity or for enterprise use has caches and multiple levels of storage. If all storage is zero access time, why build caches and multi-tiers? The answer is it does matter. Size, cost, and access time are connected. Big, fast, and cheap is a contradiction. If you want to store all your corporate data in your data ocean, going back to the dawn of time, which is exabytes, it ain't going to be cheap. And it ain't going to be fast. If you want to randomly access it, for example, you're a financial institution who wants to keep 7 years of all customer transaction statements online, you might recognize that application, might even be a user of it. That means you got to store a lot of bits that aren't used very often, but when people use them, they frequently go back to the same statements. This is level migration, obvious case. So anybody who tells you cheap, fast, big, there's a lie there somewhere. So let's go forward. What is a Files 11 volume? Well, I'll quote Andy Goldstein from 1975. It's an ordered array of block addressable storage. Block 0 to block N. That's it. Did he say anything about cylinders, sectors, tracks, heads, or access time? Nope. You can put Files 11 on a floppy. You can put Files 11 on a TU-58. That's sequential block addressable tape abortion.
Just from a terminology perspective, blocks only means something VMS. Is that correct?
No. On Unix,
yeah.
Sorry, go to your favorite Linux box, type man space DD.
What's the thing there too?
It's the only outlier was IBM in the OS 360 days when cylinder head track percolated that through the entire system. And every time you changed disks, you had to reformat every index and database file from scratch. Yes, we are now into intense pain. Anybody here see the movie Red 2? The Russian, remember, the Russian says, takes out her field kit for information extraction and says, pain is not a destination. It is a journey. Yeah. I was using City University's mainframe when they decided to change from 3330 drives to 3350. The ensuing multi-month nightmare required every user to reformat every indexed data set they used. And believe me, that was bad because a lot of people used the track numbers and record numbers as part of the customer ID. Ouch. The track size on a 3330 was, I think, 13K. On a 3350 was 19K. Oops. You lost 50% of your new capacity if you maintained the numbers. If you reformatted everything, you got it back, but you had to change all the numbers. About a year after that fiasco happened, that I experienced that, IBM came out with an announcement. We are now have a new method of organizing mass storage for fixed block architecture. Sound familiar? Yeah, about the same time too.
I always wondered.
Yeah, we got IBM labeled things by tracks in the mainframe world for many years. And then experienced the conversion. Ooh, that hurt. They learned their lesson. Blocks are blocks, blocks, Linux, oh, Unix picked up on that. All of Unix references blocks. Windows, well, Windows is derivative of basically RSX/VMS, the Dave Cutler Handiwork Committee. And he did the same, he passed on the tradition. You name it blocks, because when a manufacturer comes out with a change in technology, you don't have to break all your images. The art of compatibility is not breaking everything in sight every time there's a change. And yes, I do use these as exemplars. When you do architecture, I have a separate architecture speech I gave on my IEEE speaking tour. It's all about defining what you must define and not what you need not define. Because deciding too many issues gets you stuck in a cul-de-sac. Notice, how many times have we rewritten the I/O interface on VMS?
Sure.
The only partial exception is perform, and not really. It's basically QIO is from VMS 1.0 or day zero VMS, whatever decimal level first came up alive on the 780, has been basically unchanged till today. VMS QIO differs from RSX QIO by one parameter, AST pawn. Other than that, they're the same. That goes back another several years. There's a reason. It defines what needs to be defined and not what doesn't. The answer with storage is going to be on the same vein. You don't want disruption, you don't want downtime, you don't want unavailability. These are evil. All of these require going to senior management and asking for dispensation for something. You can do housekeeping load as long as it doesn't interfere with mission. That means using it in appropriate quantities. Growth works, shrinking things is harder, because you have to be incompatible at some point with something. It can be done, but you have to be very careful about it. One of the things people screw up or misconstrue is they think linear. Wrong answer. It's hyperspace. These are independent axes. Host-based volume shadowing is a facility. What you shadow, such as RAID 1, RAID 0, RAID 5, is independent of host-based shadowing. Striping, which is RAID 0, independent question. Controller-based RAID, independent of shadowing. Think about this for a minute. You have a volume. You decide, for whatever reason, that RAID 1 is no longer a good idea. You want RAID 0, 1. You want to stripe and shadow. You've done the spreadsheet analysis, whatever justification you need. You will get better performance from striping and stripe shadow combo. Or more commonly, you have RAID 5, and you've discovered that RAID 5 costs you a lot of performance, and that the economics now favor RAID 0, 1. That's fine. How do you convert? Well, without host-based shadowing, it's downtime and a backup. Host-based shadowing, you add the RAID 01 volume as a mirror to the RAID 5 volume. You now let it synchronize. You now create another volume, RAID 0, set volume 01. Let it synchronize, and then cut loose the RAID 5 volume. What happened? You upgrade. Do the 50 users who were logged in doing development have any awareness of what just happened?
A little performance.
Besides time, besides that is the, by the way, performance is the subject of my speech later.
Oh, how are you gonna get to that?
No. Different topic, different presentation. But have they perceived the change?
No.
Zero. No downtime, no editing sessions interrupted, no debugging sessions interrupted, no commitments missed. Somebody, you look at your IO load and you say, uh-oh, somebody's running a big test, this is slowing me down. Go in, change the parameters of how fast the shadow set, what the limit on how fast the shadow set converges is. And
Is that a priority setting or something else?
it's, I think, oh, I forget the exact parameter. It's dynamic though. I
You can
believe
change
it's
that.
dynamic, you can drop it down. You do these things. This can be done. But it's all under control. There's no brick wall here. The brick wall is changing to DS devices. That's a reboot. Because the shadow enabling parameter has to be at boot time. So the kernel code loads.
That's your shrinking.
No, that's not the shrink problem.
Oh,
This is you have to take a reboot to change from direct device names to DS names. Because you have to turn on shadow.
do that.
Hmm?
What would be who would do that? Once you've got, how would you go back to DSA?
No. When you go from DG or DK or whatever to DS, that requires a reboot. Because you need to enable shadow. And that requires certain modules to load in the kernel and so on and so on and so on. You have to enable the shadow license and that. That requires a reboot. That's a 10-minute reboot. Changing, also you have to change the SY logicals, any group logicals you have that point to physical devices to point to the appropriate shadow members. That's a 10-minute or so reboot. It's not a big deal. But it requires a full reboot because remember, you have to be careful. You can't have other members of the cluster referencing the devices while they're being switched to shadow.
Just to go off on a tangent, a lot of companies take pride in the fact that they stay up for years. The problem with that is there's a quick reboot. Startup procedures have changed. They haven't been tested. You don't reboot.
We'll get there. I could get there in a separate session. See me offline.
Yeah, I said, I knew it was a tangent.
It is a tangent. I can talk about it offline. There are ways to deal with that. The answer is basically, there are multiple ways to address that. See me offline.
Yeah.
So each of these items, think about independently. Don't get into thinking multiple axes at the same time. You'll give yourself a headache. And it confuses, it doesn't help the conversation. Separate it. It's much more intelligent to talk separately about each of these issues. What is disruptive? Because disruptive events are a problem. If your storage bitmap is not full size and you increase the size of the volume, you hit the buzzer. Take volume down, reformat volume with backup, big downtime, painful. Can you get around it? Yeah, you can use search lists, logical disks, and so forth to make it follow. You can take the physical volume, split it into two logical volumes, mount them as bound shadows, as bound volume set, and use a search list, and therefore expand the volume in spite of the fact that the bitmap is too small. Ooh, that hurts. And that has other issues. People don't like doing that. Okay, when you initialize a volume in today's environment, make the bitmap as big as you can be. By the way,
See the future.
Hmm?
See the future.
yes, the most important, we don't have many of them here, but oh, I can lift this one up. The most, oops, it'll come back, maybe.
Oh, so
Where is the power switch? Give me a second here.
can I put my glasses on?
No, there it goes.
Somebody. It's just a commercial break. That's.
Yeah, remember something. There are 1, 2, 3, 4, 5, 6 outlets on this strip. The standardization of that plug design. Say again?
Not observed by everybody.
No, but it was quickly discovered that if electric razors have a different out plug than projectors, which have a different plug, ... it makes for a mess. Same problem. Big volume, bitmap size is insignificant statistically. Don't make it your problem. Same thing with index F. Index
Where's the F?
Index F has to have one file header. That's a problem. If you allocate too few file headers, you get beyond one volume. Even if there's millions of blocks available, you can't use them. You have to restore, you have to defragment the volume. Ouch, downtime. Don't do it. Blocks, storage sizes are such today that you can create a large index F. Index.sys without worrying about
What is
index.
index?
It could be, I may have typed it bad.
Or in the spell check.
Yeah,
It is supposed to have that.
I thought so. I'm conditioned. Problem of proofreading your own stuff is you're so conditioned to expect what you're expecting that you just fly by it.
Or the spell checker.
No, I won't blame that. If you change global directory structures, that's an application's pain point. Because things are running with an implied path. When you move the path out from under them, it hurts. Changes in file ownership, same story. Things hurt. On bitmap, the biggest bitmap you can allocate is 65K blocks. Really? On a terabyte volume, that's important. It's a drip in the bucket. Allocate it. By the way, when you decide the size of a cluster on the disk, consider carefully what your underlying medium is. Default VMS system disk comes with a cluster of 3. Many people pick things like 17 and other things based on old hardware configurations. Well, ever since we went to HSCs and stuff like that, you frequently have external devices who work in multiples of 16 blocks. It's extremely beneficial that you don't have breakage. Just like you want quad word alignment and such in main memory, you want disk clusters to align with whatever is the underlying storage or quantum.
You don't want it to be. You don't want it to be a prime number.
No.
But I've always seen 17 and
Yeah.
11.
It used, well, 17, some of these numbers have, you have to track the genesis of the number. Many people allocated half tracks on 3330s. It was deliberate. It meant there was no breakage across a cylinder. Yes.
Install several systems now, and they changed it to default of 16.
That's because of the HSAs, yes.
Yeah.
And the disks are bigger now.
Yeah.
When the disks were really small, 13 to 16 caused a 25% breakage factor. I had one systems programmer back when I was in college. On our first VAX, set the quorum to half track. In those days, a RPO6 cost 35 grand a pop, and we didn't have a budget for it. I did a dir/size/tote, and I was able to discover we had 25% of our disk space in breakage tied up.
It's like unattainable.
That's breakage is, I need 6 eggs for the recipe, but they only come in boxes of a dozen. So I end up taking a dozen eggs and throwing the other 6 in the garbage. Oops. When you're paying 35 grand per drive and 20% of it is tied up by 1 block files,
Just
allocated but unused, it hurts.
Especially if your business involves a lot of 1 block files. And
This is one of the reasons for using LD, by the way. You can split a disk and put the small files on an LD, which has a smaller cluster factor, and put the databases, which are gargantuan, on a disk, which has a large cluster factor.
we didn't think of that. The way we handled it was we found those little files out there. And then anything that was older in the day, we bolted into a text library.
You have to be careful. That's not transparent. I'm talking transparent.
Yeah, I know.
The trick is, and that, by the way, I say transparent, you can also use bound volume sets for that as a gimmick. There's a trick there. But I digress. The point is that there is a reason, and defaults are defaults, but you have to go look at what they really are and why they're what they are.
Can you do it per shadow set, or does it have to be all the same?
No, has to be, it's per files that are in volume. Remember, a shadow set is block by block, identical. So you have to be careful. But defaults are not religious texts. They are defaults. Before you go to something, doing something long-term and important, take out your scratch pad or a blackboard, whatever your favorite computing medium is, and work out what you're really doing and why. Haste makes trouble downstream. Bitmap, not a problem. Size of bitmap, not a problem. Okay, headers. Yes. I'm entitled to typos. I'll fix them and put up the correct slides. I don't claim perfection. I just try.
Actually, I think the spell checker
No,
doesn't check capital.
doesn't matter. I don't use Word or PowerPoint. This is done with PostScript. The default for file headers is ridiculously small in today's context. Allocate something sane, but it is limited to a single file header. Fragmentation is your enemy. Be generous. Directory structures. You are making a commitment long-term. You have to stay with it. Be careful. Choices. Once you make choices in haste, you're stuck with it. Big change, a small change up front is not a problem. A big change is a big problem.
So we're talking about trying to balance files.
No, no. I've had people, for example, make it a point of putting different groups in different logical trees on the disk.
Different groups, like.
Different departments, different.
Yeah.
Why different trees? Some groups will need a backup on a different frequency. Some groups need privilege issues. Some groups, when they log in, have a certain context that they need to establish. That's a group logical name issue. I wrote a blog article on that. You can have a group login by using a rooted logical name and directory 00, in that have a group login file that is executed automatically by the SY login. But if you do this in a hierarchical way at the initial point, it's part of the woodwork. If you come around 6 months later and start trying to put it back in, it hurts. Users get upset. This way you do it from the beginning. Same thing with applications. If you have different trees per application, and you want to have deployment of application versions and you want to stage it, it's all a logical name in the group logical name table, which is keyed off the group login, which is keyed off. You see where I'm going with this? You're all pre-configured to do what you want to do. If you start doing it later, it gets hairy. The goal of all of this is to avoid putting yourself in an interruption mandatory situation. If you do it right, you can go from a desktop VM. I've done things like this. You can go from a desktop VM running a demo of a situation to a standalone workstation, by the way, without interrupting availability, to a cluster, to a, yeah, you use clustering to get from one to the other, but a real cluster with 2 operating nodes simultaneously or 3, using external storage, also without interruption, going to something bigger with multiple enterprise storage arrays without interruption. And you've basically had continuous availability for the whole time. You've never, ever bitten the bullet. You've gone from stage to stage to stage in a controlled way without any excitement. There's a book I read when I was in junior high school. It was junior high school. It was written by a retired naval officer. And one of the comments, a submarine officer, Ned Beach, who was retired as the President Eisenhower's naval aide. But his comment in the book, which was a novel set in World War II, was his captain always passed orders by telephone when departing and arriving. He put a talker with a telephone. Today you use walkie-talkies, but they didn't have them in those days. There was a talker with each line party, and he issued orders to his yeoman through the telephone circuit. Why? Because shouting through a megaphone gets people have mistakes, they don't hear, there's competing background noise. There's lots of problems that happen. It's much more quiet and controlled, issuing orders by phone.
In the brain.
Yeah, it's that
Baby cries, something happens.
you keep it quiet. It is very routine. This is as if you ever watch a NASA control room or a air traffic control center, it is very under excited.
911 calls.
What is the nature of your emergency? Listen to the tapes. There are some classic tapes, like the Flight 1549 incident. What is the nature of your emergency? This is as cool as can be. No shouting.
Oh my God.
Nobody gets excited. There's nothing gained by shouting. If you avoid reorganizations, that's one problem out of the way. Now, how do we use this? There's a little feature called dynamic volume expansion. Now, remember, I may have said, I don't know if I said it earlier in this talk, I was just saying in the hallway, VMS is very good about giving you features. And oftentimes, engineering's intuition on what the feature should be is pretty good. Their batting average is good, not 100%, but good. But they don't always put the pieces together for you. This is one of them. It turns out the rule on shadow sets must be the same or larger when you add a shadow set member. Part of that is simple hardware engineering. The disk from 5 years ago is generally smaller than what's available now. So you may have a spare parts problem. So it's not unreasonable to say that you put a 200 gigabyte drive in as a spare part replacement for a 100. The 100 just may not be available anymore. As long as you are willing to ignore everything past 100, it's a perfectly valid file structure. So you can have the similar size shadow, as long as the new volume is bigger. Keep that short. But if you do that, it would be nice to get all that space. Well, that's what dynamic volume expansion is. It'll reset the high block number. It will not expand the bitmap, but it will reset the limit on where the volume ends. Or is the light starting to dawn? Watch. You initialize the volume with maximal bitmaps as you can go. You just slam that to the wall. Now, what do you do? Well, first of all, you can do this on a VM. I did it on my workstation, on my little laptop under Virtual Alpha. I just don't like doing demos in real time. My typing isn't good enough. What do? You initialize the volume set at a small size. And if you want to try this at home, do it on a virtual machine, on one of the architectures or one of the emulators, on your laptop. It also is shorter. 10,000 block volumes to 60 is easy on a laptop. Dealing with multiple gigabyte volumes takes a long time to sync up each step. 10,000 blocks proves the concept without taking more than a couple of seconds to copy. Okay, you start with 15K blocks. You have a shadow set. Yes, I use logical disks for this. Once again, demo purposes. You add a 30K block volume to the shadow set. Let's assume you limit your shadow sets to 3 members. SPD issue. The limit is actually higher, but they legally, I think the limit is still 3. You drop one of the small volumes. You still have 2 members of the shadow set. One of them is 15, one is 30. That's perfectly legal. Now, add another 30. You now have a 15, a 30, and a 30. Have you interrupted users? Nope. Has anybody known what you're doing? Nope. Is the web server still running happily? Yep. You bet it. You betcha. Now, you drop the sole surviving 15K member. What can you now do? You can now do set volume. You can now use volume expansion to move it to 30. Look, ma, no hands. Say again?
That can happen in real time.
Pretty much.
I thought, and it was kind of a boot thing. I thought the knit was really a boot. You couldn't do it while the
Init, you can do init anytime you want on a volume that is privately mounted. You then can add it to the shadow set. Adding it to the shadow set does not interrupt shadow set availability. These are actual cut and pastes from my screen. You just keep doing this process iteratively. Now you have 14,003 blocks.
Go back to the beginning. Got it.
It's very simple, very quiet, very routine, very blasé. The key is you're never operating on something which requires you to take the system down. Enable it. Certain things do require you to take the system down. Turning on volume and extension. Yeah, that you require to dismount the volume. Doesn't require the system down, it means the volume has to be down. That requires you to programs, that's a bad thing. But if the shadow set is created, remember I said you have to take one downtime? This is the things you need. Downtime is turning the volume into a shadow set volume. It's making sure it's dynamically expandable, changing references from changing the logical name references from the actual device, physical device name to DS.
One time, thank you.
Pick a 15-minute window. Put the file, the new files in a place where you can just rename, and boot. I had one site where I had 40 volumes to do. I wrote up scripts. Machine is going down at midnight. Down she comes. SY Logicals was, I blocked SY Logicals, came back up, swapped the file, take her down again. Change the to expandable, change the necessary things I had to do. Reboot. We're back. Verify everything's where it's supposed to be, make sure everything starts up. We're done. Don't try to do too much in a downtime window. Allocate 2 hours, give it back after 15 minutes. If you can. By the way, I'm going to say this right now. Invariably, managers want to create a non-compliant second system. The number of times I walk into a site and find a production system and the quote test system is not conformant. Really bad idea. Because you can't test all the evolutions that you need to test on the test system. When you build a clone for testing, it must, as my French teacher used to say, the verb must agree in number and gender with the noun. He wasn't kidding. If you have a test system for a production machine, and a production cluster, let's say, it needs to be an exact clone. If it has an HSJ, the other one has an HSJ. If it has an MSA, it has an MSA. If it has a certain model of switch, yep, same model of switch. Same firmware levels. No, I'm sorry, the test is always the firmware ahead. So you learn on the test system what doesn't work. If you have shadowing on production, you have shadowing configured and active on test. Because you do this right, every step you do on production must be done precisely on test. And when I say precisely, I mean, read that as until it works, until you can do it, you bloody sleep. That is correct. The moment you start hand typing and free agent is when you get into trouble on a production system. Every time I've had one of these go sour, one of the root causes is we couldn't run this test on test. Wrong answer. You saved $100 on software licenses. Bravo. You just cost us an 8-hour downtime. It ain't worth it.
You don't have a test.
Then you build as much close as you can with a bunch. Okay, I'm going to say it this way. I have sitting in one of my racks a Geecom PC. Costs about $500. It can run, it has 64 meg of memory and can easily run VirtualBox with several VMs. It can host its own cluster. The second best thing to having exactly the same physical hardware is a logical doppelganger of limited scale.
I gotta go with option A.
If you Believe me, if you have a high value production cluster, option A. If you have a problem with getting access to the test environment, as in it's overbooked, option B is a damn good supplement. It allows you to do everything you need to. It's not a bad feed through pattern. Everybody can have their $500 cluster on their desk and do what they need to do. And then when they pass there, they can bring it onto the real test hardware and verify it there. And then you can go play with the production machine. It's all a question of cost. If you're a school and you're talking about a library where you can take it down at 3 a.m. for a day, as long as it's not finals week,
Right.
that's one thing. If you're mission critical, different conversation. You keep rolling forward like this. Okay, you move files, perfectly normal, nothing exotic. Shadow set displays just like you'd expect. Members exactly as you'd expect. Now you have a crisis. As most crises, they come up without much warning. Somebody decides, oops, we're running out of time. Somebody runs out of space. Okay, do the same thing you did originally that we showed before. Create a shadow set member. Add the bigger member. Release. Add, release. And now you're at the bigger size. And you can do this ad nauseum. Now, remember what I said about RAID 1 and RAID 0 and RAID 5?
Yes.
A logical volume on a storage array looks just like a volume. Therefore, you can go from RAID 0, or you go from just a disk to a RAID 1 set by just doing a host-based shadow copy to a RAID 1 set. Hardware host-based shadowing is completely independent of what the controller is doing. So you can have a RAID 1 volume set on a logical storage controller and just make it shows up as one physical unit. As far as the host is concerned, you can use it as a target, a member of a shadow set. And voila, you now have a shadow set. You've reorganized it. Have you interrupted the users? Nope. Want to move it to RAID 01? It's a bits. Bingo, you're done. Time to completion, as long as it takes to do the copy, which you can control. Want to move it, you have say a P2000 storage array, which is fairly long of tooth at this point, it's de-supported. You buy a shiny new MSA 2052. Just add the volumes to this, make sure the numbers don't conflict on the SAN. Make sure you have access to the volumes. This can be done all while the system is running, because volumes that aren't in use, you can do what you want with. Qualify everything to make sure everything works as advertised. Start adding the new volumes to the shadow sets. When you're happy, delete the P2000 off the cliff. When you're finished, unplug the wires. Has the user has Apache had to be shut down? Nope. Has anything else have to be shut down? Nope. Is anybody aware of what's going on? No. Okay, the guys who do showed DSN get to see the shadow set names changed. Move something from storage pool A to storage pool B on an MSA. Same story. Create a volume. Move it to the shadow set. The bits move. All measured, all very quiet, all very not under the radar, but not a high profile on the radar. No interruptions, no mess, no problem. Any questions? Sorry, I ran out of time. Give me about 2 minutes. That's the way in my opinion, this is the way you do it. Now, a note. If you contemplate doing this, I advocate, and I put it in writing before, that VSI offer a limited shadow license, limited to one shadow set member at a very nominal cost. So you can upgrade for the transitions and then downgrade back. That's my personal opinion as an individual. But even if you have to pay the full price, if you've got mission critical tier, you pretty much already have shadowing available to you. So if you have shadow licenses on your machines, I'm going to tell you to make everything a shadow set, even if it's only one member per shadow set. Because when you need to upgrade, when you need to expand, when you need to change your storage environment, this pays infinite dividends. You don't have to do that shutdown reboot. You just enable shadowing from day one, even if it's a degenerate shadow set with one member. One member, one physical drive per shadow set member. That leaves you the option of hot plugging drives in and moving data, independent of control. Questions? Thank you for attending. Hope you enjoyed it.